So we do have one question here that I guess we can mention about. The question is from Amy. What about those of us who see really old stuff, e.g. a 20-plus-year-old central air conditioner unit with SEER about 4? I don't see many splits on space conditioning. How should these be handled? With respect to the first question about a air conditioner with a really old SEER, so like I just demonstrated for creating an 81% FUE boiler, you can certainly create your own air conditioner option with a lower SEER. Over time, one of the things we've done in BEopt version 2 is that we have provided a lot and shipped a lot more options in version 2, and we expect that we'll continue to expand the set of options that we ship. If you don't see an option that we ship, you can certainly create that option yourself, but you also might suggest that we include additional options by default in BEopt for all users if you're seeing there are some gaps in some of the options that we ship.
And in particular for air conditioners, in the current version of BEopt and maybe 1 or 2 versions back, we did generalize the air conditioner modeling from what was used previously and what is typical for DOE2 Energy Plus simulations that involve, as you may know, performance curves with a large number of coefficients that in those circumstances is very difficult to develop user-defined air conditioner options at different SEER levels. But in the version 2 of BEopt, that's fairly straightforward to do. And mini splits are on the to-do list, coming soon, I would say.
Are there any additional questions on the phone?
No questions have queued at this time.
Okay. We're getting a couple more questions here than submitted online. Austin asks how difficult it would be to change a search algorithm. I'm thinking along the lines of genetic algorithm. That's an interesting question. And I personally have done a fair amount of work on specifically the optimization search that BEopt uses. And I know that there has been some work, for example, at the University of Colorado to compare the search algorithm that we use in BEopt to some separate algorithms, and I believe genetic algorithms was one of those that was evaluated. Early on in BEopt, we had a different algorithm that we used that was simply meant to identify the single best zero net energy building in terms of cost. And so it would sort of hunt around, and you'd get sort of a scattering of points, and then you'd get sort of a single building design that BEopt thought was the best building for zero net energy. We backtracked a lot and went with this search algorithm to try to fill in a lot more of the points so that we can, as a program, for example, evaluate what it takes to reach 30%, 50%, 70% energy savings, as well as the search technique has the advantage of providing a lot of alternative building designs that you can hunt through on the output screen and evaluate. So there's not just a single building design, there's multiples. So we have a lot of reasons, I'd say, that we went with the search algorithm that we did. But I don't know that we're particularly tied to it. Perhaps if there's interest, Austin, we could talk more offline about your interest in wanting to use a different algorithm. We have found, and I guess we didn't show it today, we often, when we show this presentation, we show the benefits of our search technique relative to brute force, running all combinations of building technologies, and we tend to say that the search technique that we use is on the order of 1,000 times faster than the brute force approach. And as we do optimizations in BEopt 2, it takes sort of a couple hours, which is not real bad. So we're pretty satisfied with the technique, but happy to discuss that more offline if you'd like.
And Austin, if you want to shoot us an email, I believe we could track down the University of Colorado master's thesis that Scott mentioned that might be of interest in terms of comparisons for different search algorithms.
Okay, a couple more questions are coming in here. Dennis asks, in airflow, perhaps a setting for mechanical duct resistance as a means to indicate undersized or poorly implemented air ducts, and solar hot water and solar air. So I'll maybe talk briefly about solar hot water, which is to say that solar hot water is a technology that we have. At the moment, it only shows up when using Energy Plus because DO2 does actually not have the capability to model solar hot water systems. But if you switch to the Energy Plus simulation engine, there is a solar water heating category that shows up here. We've got a couple of closed loop systems, as well as the ability to define the azimuth and the tilt of those systems.
And this is Eric Wilson again. With respect to the airflow question, I think this is a good suggestion and something we've thought about in the past, so thanks for bringing it up again. I think it is something that we would like to include someday, you know, the ability to specify an airflow rate that's less than what would be recommended and account for the energy impacts of that. So thanks.
And I guess solar air, I'm assuming that's meant to be some sort of solar space conditioning system, a combi system perhaps. Certainly that's something of interest to us. We've got still, as you can imagine, a lot of technologies on our list of things we'd like to be able to model, and it's just a matter of prioritizing them over time. And so certainly we'd like to add this in the future. It's just a question of at what point we can add this capability. And it looks like we've got a question from Ari. Wanted to know if you could describe how BEopt 2.0 handles the heat transfer via ground coupling between the ground loops of a ground source heat pump and surrounding soils.
I would refer this question to the Energy Plus documentation or DO2 documentation, depending on which engine you're using. There should be, especially Energy Plus, should have a good documentation of the engineering calculations that they're doing within that simulation engine.
And there's nothing specifically that we're doing on the BEopt side other than modeling the technologies in DO2 and or Energy Plus. And you can always certainly investigate the input files that BEopt generates as well when you have a ground source heat pump to understand the inputs that BEopt is providing to those simulation engines.
There's one comment that I'd like to make about ground source heat pumps, and I think maybe you could go to that category, Scott. If there's notes at the bottom of the screen, and I think it's mentioned here that, as you can see from the options in this category, there are options for for low and high soil conductivity or conductance and standard and enhanced grout. The one thing that you'll find here is that as you choose these better, worse, or worse options, that what happens actually is that it doesn't so much impact the performance of the system, but it impacts the cost. So that's to say that if you were in a favorable situation with high conductivity soil and enhanced grout, you would have fewer feet of auto-sized ground heat exchanger and therefore a less expensive system. And so this is what BEopt is doing, is kind of designing the system according to best practice. And what that does is give less heat exchanger and therefore lower cost, as opposed to seeing the performance go, the energy consumption go down. So that's something to bear in mind as you look at different options.